Hi everyone. Today, for this video, we're going to look through the junction rule, which is the last new thing that we have to cover for the circuits unit. It's a little quicker, a little more straightforward than some of the other stuff, so let's just kind of dive right in. A junction in a circuit is an intersection. So it's any place where the wires connect and where the current has the opportunity to split up. We've actually talked about junctions, although I don't know that I use that term for it. What I mean by that is this. You don't have to write this part down. But if we've got a battery and a resistor and another resistor, what I actually drew here is two different junctions. Junction is the word we have for that intersection. So the junctions are here and here. Here's what makes them a junction. If you were an electron, imagine like a bunch of electrons traveling through the wire. They come out of the battery, they travel along the wire, and once they reach this junction right here, they have the opportunity to split up. Some of the electrons will go this way, some will go that way. So you kind of get to pick which way you go. What happens is like more electrons go through the path with a lower resistance, but that's not super important for what we're doing right now. What's important is that this is, again, a junction where the current can split up. All of that current, it travels through our resistors, and then it meets back up at this junction again. So all that current, it meets back up at this junction. It meets back up at that intersection between wires, at that place where the two wires come together, and then it travels along the wire. So, at these junctions, we have something that we call the junction rule. And it's basically this. It means that the current in is equal to the current out. It's kind of the way I could say that with the least amount of writing on my stylus surface. So the current going into the junction is equal to the current going out of the junction, which is something that kind of makes sense if you think about it in the right way. So to do that, let's think about an intersection that's maybe like you're a little more familiar with. Let's talk about like a road intersection, and instead of electrons, let's talk about cars. You might have noticed I like this analogy between electrons and cars for this unit. So let's look at this intersection right here. We've got two roads sort of meeting. We've got a couple cars going this way, a car going this way, a car going this way, and I know that none of these cars are following the proper like lanes, like rules and stuff like that. But that's not the point. So we've got a couple cars here, a car here, a car here, and what I want to know is like how many cars should be going through this other road right here? That's what I want to know. And again, think about an intersection. The amount of cars that enter this intersection should be equal to the amount of cars that leave it. Like imagine if like 5 cars went in, but only like 3 cars came out. Like, well, where'd the cars go? Is something eating them? Like, what's going on? So that's basically the junction rule in sort of its simplest form here. Is that the cars going in has to equal the cars going out. So something that I find helpful is I like making a chart. You guys know that I like charts at this point of the year. So I'm just gonna make a quick list of all the cars, like how many cars are going into the intersection and how many cars are going out of the intersection. And I'm gonna use that to just kind of help me out here. And I know the numbers aren't super complicated right now, but if they were complicated, a chart might be helpful. So I'm gonna write down let's say in, out. And again, I'm just going to kind of list all the cars that I know, and then hopefully we'll be able to figure out what's going on in this missing, for this missing value. Alright, let's change colors here. Let's start with these cars. No, I don't like that color. Yeah, let's start with these cars up here. Are they going into the intersection or out of the intersection? I would say that they're going into it, like they're approaching it, they're driving towards it. So I'm going to put those here, like 2. And I'm going to write 2 because there is 1 car, 2 car. That's where I got that from. Let's do this guy right here. Alright, well, we're traveling that way. I would argue that that's traveling out of the intersection or away from it. So I'm gonna put like a 1 because there's only one car there. Down here, oh, I screwed this hole. No, I didn't. So down here, down here. Sorry. Down here we got this one car. Is it traveling into the intersection or away from the intersection? I would say that it's traveling into it. So I'm gonna put a 1 here. All right, I'm gonna add these all up and see where we are. So 2 and 1 makes 3 cars going in. And only 1 car coming out. Well, that doesn't make any sense, does it? Because how can you have like 3 cars go into an intersection but only have 1 come out? So what's happening in this missing branch of our intersection? I would say that there's probably 2 cars, and they're probably traveling out or away from the intersection. Oops, no, 1 plus 2. Notice what that does for us here. See how we had 3 cars going in and 3 cars coming out? That makes sense. If 3 cars go into an intersection, you should have 3 cars come out of it. And that's basically what we're doing, but we're going to do it for electrical current. So you can think of it in kind of the same way. So I'm going to redraw this problem, but for electricity rather than cars. Okay, so here's what we're going to do now. This is not in your notes, so just kind of like watch this and follow along. We've got some current moving through a circuit, and we have an intersection here. We've got like a wire that goes downwards. We've got a wire traveling this way, crossing a wire that goes this way. And I'm going to give you most of the information for this. In other words, we've got 2 amps of current traveling the way that the arrow shows. We have 5 amps of current going towards the right here. We got 7 amps of current going down. And then I threw in an ammeter on this branch of the circuit. And I want to know what the current is through that. So I'd like you to do 2 things for me. I want you to tell me how much current is going through it, and which way is it traveling, meaning like to the right, into the intersection, or to the left, away from it. So let's do this. Again, the current going in has to equal the current going out. You can't have like 100 electrons go in and like 3 electrons come out. Doesn't make sense where those other electrons go. Just like the cars. You can't have cars disappear at an intersection. You can't have electrons disappear at a junction. So, again, there's not like a lot of numbers here, but I don't know, I still find it helpful to organize myself. So I'm going to write down all of the current going in. I'm going to write all of the current going out. And again, these have to be equal to one another. So let's just kind of list it all, and we'll figure it out. So I'm going to go 1 branch at a time here. So you see this 2 amps? And when you think, which way is that going? Is it going into the intersection, meaning into this junction right here? Or is it going away from it? I would say it's going into it. It's going towards it. So we're not doing like an up versus down, a left versus right, or anything like that. We're doing towards versus away. Are we going towards that intersection, or are we going away from it? Okay, this 5 amps is going to work clockwise here. The 5 amps, is that going into it or out of it? I think it's going out of it. Out of the intersection. It's going away from it. And that's why I put it in the out column. That's 7 amps. I'm looking down here. Is that going into the intersection or away from it? I would say it's going away or out of the intersection. So I'm going to put a 7 in the out column. And I'm just going to tally this all up and kind of see where this leaves me here. We've got 5 plus 7. I think that's a total of 12 amps coming out. Again, think of it like 12 cars leaving an intersection. And I think we've only got 2. Okay, so again, what I told you is that these 2 columns have to be equal to one another. So what we have right now doesn't make any sense at all, right? How can you have 2 cars enter an intersection and then 12 come out? There's like no car factory there. And as far as current goes, there's no like current factory there. There's no electron factory in the middle. So we got 2 amps coming in, 12 amps coming out. How much, like, what must be going on here in that other branch? I think it's 10 more amps going into the intersection, and so that would be our answer. Okay, that in mind, I'd like you to try question 61. Do it on your own. Pause the video, give this a shot. I'm going to walk through it in a second. But try question 61 on your own. Basically what we're going to do here is for all of these missing, all of these branches of the circuit where we don't know the current, I'd like you to tell me what is the current, and then just draw an arrow telling you which way it'll go, meaning like, is it going this way or is it going the other way? Give that a shot for me. In a couple seconds I'll go over it, but again, pause it, try it on your own, see what you can do. Okay, so I'm hoping you try this on your own, but let's go over it together. So for this one here, we've got 5 amps this way, 2 amps that way, and we're trying to figure out what's missing here. And again, I'm just going to take sort of an inventory here of what's going in and what's coming out. Alright, let's start with the 5 amps. The 5 amps I think is going in, and what I mean by that is, like, say it's going like towards the intersection, like towards the junction. So I would say that's going into it. 5. That 2 amps, I would say, is going out of it, because he's traveling away from it, so 2 coming out. And again, these 2 columns have to be equal to one another. Right now they're not. 5 in, 2 out. So I'm going to add another 3 to this column, because see how that would make them balance. Now you've got 5 in, 5 out. So we've got 3 coming out, or going away from it. So I was looking for 3 amps. And if you're doing the direction, it would be like sort of towards the right, or out of the junction. Okay, this one right here. Notice it looks really similar. The only thing that I really changed was I took that 2 amps, and instead of going this way, I changed it to going this way. And let's see how that changes things. So we've got our ins and our outs, and let's just kind of see where this takes us here. The 5 amps, I would say that's still going in, right? It's still going towards the intersection. So I'm going to put a 5 on the in column. This 2 amps, it's traveling, I would say it's going like towards the intersection, right? Imagine like you're one of these cars. If you're traveling this way, you're going into the intersection. You're going into the junction. I'm going to put this 2 here. And again, these 2 columns have to be equal to one another. We've got 5 and 2. I think that makes a total of 7 going in, and a total of nothing coming out, which doesn't make any sense. So how much current should be coming out of that last branch? I would say it's 7. 7 in, 7 out. And that's our answer. So I'm looking for 7 amps, and if you put a direction to it, this way. Alright, last up. If those previous 2 were like sort of obvious to you mathematically, then this one, I'm just gonna, buy some space here. If those last 2 were kind of easier for you, then that's great. But for this last one, there's an awful lot going on here. We've got 1, 2, 3, 4, 5. 5 different branches of our circuit here. So this is one where it really might be helpful to list what's going in and what's coming out. Okay, we're just going to go one at a time, and I'm going to circle each of them once we have them listed. So this 10 amps, I'm going to say it's going out, because see, it's going like away from that intersection. So I'm going to put a 10 in this column. I'm going to do this 1. It looks like that's going into the intersection, or like towards the junction. So I'm going to put a 1 in this column. Oop. Okay, so for the 12 amps, it looks like we're going, I would call that out, like away from it. It's traveling away. So I'm going to put that 12 here. The 7 also looks like it's going away or out. So I'll put the 7 in the out column. And, okay, I think that's everything, right? So let's tally these all up and see where that leaves us. 1 is 1. And then 10 plus 12 plus 7 is 29. Obviously, those are not the same number. So, what would we have to add to the in column to make these balance out? 28 amps. Specifically going inwards, towards the intersection. And so that's the junction rule. It's just this idea that the current that goes into one of these junctions, again, they're just intersections for current. The current going into a junction is equal to the current going out. So for these, list the current that's going in, list the current that's going out, and see what you have to do to either column to make these balance out. There's a quest assignment. It's literally one question long, because this is the only question I could find on the junction rule. But give it a shot. I'll post the video solution to it as soon as I get around to it.